Hello, dear students. I am Apratim Chatterjee, Assistant Professor of Sri Ramakrishna Institute of Science and Technology in the Department of Electronics and Telecommunication Engineering. In this session, I'm going to be discussing about a special topic that is antenna designing and simulation. So we have been studying antenna in our colleges, in our semesters. We have that topic. So this particular subject is regarding digital and microwave communication, and this particular aspect of designing antennas and simulating it falls under the category of microwave communication, because I think you all know that microwave communication means high frequency, transmitting high frequency signals, right? High frequency means they falls in the range of megahertz and gigahertz ranges. Now, the way we communicate in our day-to-day world, I mean, this world is connected by globalization. It's all possible because of telecommunication, right? So the communication bandwidth that we have in our world today is 4 gigahertz to 8 gigahertz. That is also called the C band, or the commercial band, right? Now, so it's in gigahertz. That means it falls under microwave. Now, in this particular session, we are going to be looking into how to design a particular antenna that is called microstrip patch antenna. This special type of antenna is a very lightweight, miniature, small size antenna, especially used. It can be used in our cell phones, in specific gadgets. It also can have applications in missiles and rockets and all such stuff. Okay, so it's a very popular antenna, microstrip patch antenna. We're going to be designing that antenna and simulating it. Now, simulation. This term is especially used in our modern day industrial world. Okay, because in the industries, it is times have changed. Okay, now suppose you want to let's say you want to make a small piece of let's say small piece of some item. Let's say you are going to make up let's say an image of something, right? So you don't always need to go out and take a piece of wood, or let's say you don't need to just carve pieces of it and design it with your hand, experiment out with it. You don't have to do it with the physical tools available with you, right? At this moment, right, at this age. The main reason is that suppose in any stage you fail at the experiment, so what will happen is you will lose all the resources that you have used for building that stuff, including time, money, and the materials. So industries in the present age, they rely mostly on simulation. Simulation means just replicating that, designing that experimentation, real world experimentation with the help of a software. So with the software, we first experiment the stuff. We experiment with the designs and everything. We see how it works. We see how the results are coming, and when we see that it is best suited, we are satisfied with the results we have wanted, the way we have designed it, then we go on to physically make the model in the real world. Okay, so simulation is a very important part in our industrial applications. So for designing antennas, there are many softwares, many tools that we can use for simulating them. The one today which I'm going to show you is HFSS, high frequency structure simulator. This particular software tool will enable us to design and simulate the antenna that we would have been done in a real life scenario. So let me show you. First let me show you a PDF, a visualization about the microstrip patch antenna and the necessary calculations that we need to design that, because we cannot take any random calculation, any random measurement for designing the antenna. There are well given equations for that purpose. So let us look into it for a brief moment, and then in the next part I will be going directly into the software, in the HFSS software. Well, I will be designing the antenna. You will be observing that carefully, step by step, how am I doing that. Okay, so let me show you the uh, PDF over here. Yeah, so antenna design and simulation. And now let me go to the page where we are going to focus on this particular antenna. So yeah, study of a rectangular microstrip patch antenna at Bluetooth frequency. Okay, so we all have Bluetooth in our cell phones, in our smartphones, right? The Bluetooth particularly, it operates at this frequency 2.4 gigahertz. This is the frequency of operation of the Bluetooth. Okay, so we are going to design an antenna that is going to transmit these Bluetooth signals. So this frequency that we are going to design the antenna that is going to operate in this particular frequency. Okay, now this is how the microstrip patch antenna looks like. Okay, let me show you over here. Let me zoom it for you. Yeah, so see this microstrip patch antenna, it is actually a three-layered structure. Okay, so the bottom layer is called the ground plate. It's basically just a metallic plate, the that provides, that acts as a ground of the antenna. The middle layer is called substrate. It is actually a dielectric material. It also has a dielectric constant. And the topmost layer is called the patch. Patch also is a metallic structure. Over here you can see it's a rectangular structure. It's a metallic structure called the patch. Now the antennas, they are mainly designed for transmitting and receiving radio signals, right? So this particular microstrip patch antenna radiates from the patch. So it radiates from this patch. Okay, now let me come to the equations that we need. Okay, so uh, I am going to skip this part about the mathematics and all that. Let me directly show you this website. It is called everythingrf.com. Everythingrf.com. You can easily calculate the necessary dimensions of the antenna using this website. So what are the inputs that you need to give over here? So first of all, see, the antenna that we are going to design, you need two things. First, the dielectric constant. So here I have given it epsilon r equal to 2.2. Okay, and also I have taken the height of the substrate as 3 millimeters. These two informations you are going to need, and also of course with at the frequency, operating frequencies. Let me correct myself. You need these three objectives: the frequency, the dielectric constant, and the height of the substrate. We are going to put them over here. So dielectric constant is 2.2. The height of the dielectric is 3 millimeters. You can make sure you make sure that it is in millimeters, because as I told, the microstrip antenna is a very miniature sized antenna. The frequency of operation is 2.4. It's gigahertz. Now you are going to click on calculate. So see, it has given the width and length of the patch. Okay, so the length is, I can take roughly as 40 millimeters, and the width I can take roughly approximately 50 millimeters. So I got the length and width of the patch, means over here I have got the L and the W. So I've got the length and width of the patch. I need the length and width of two more layers, the substrate and the ground. Now understand one thing carefully. Both the substrate and the ground, the substrate just lies on top of the ground plane, right? So these two will have the same dimension. The height and width of the substrate will be equal to the height and width of the ground. Now, there is a formula to calculate the length and width of the ground. The formula is 6h plus L. H is the height of the dielectric. Length over here is the length of the patch. So you calculate this expression 6h plus L. This will give you the length of the ground. Okay. For similarly, you want the width of the ground. You can calculate it by 6h plus width of the patch. So I think you have seen over here that the length of the patch is 40 millimeter. So if you put L 40 in place of L, H is 3. So 6 into 3 is 18. 18 plus 40 is 58. Right. So I can take roughly it has to be 60 millimeters. So the length of the ground I can take roughly to be 60 millimeters. And over here I can get 18 plus 50. So it will be 68, means 70 millimeters. So I have calculated the width and length of the patch. from this website. You can also do it with the equations. So from these two formulas values, I have also calculated the length and width of the ground plane. That is, one is 60 millimeter and the other is 70 millimeters. And the ground length and width is same as that of the substrate. Look at this design. So here now we are going to go into this design of the microstrip patch antenna. So let's go into this design. I hope that the theoretical portions of how to calculate the length and width, that was clear to all of you guys. Now let me go in and show you the website. The software HFSS without any delay. Sorry, yeah. So yeah, this is how the HFSS software looks like. Over here you can see that you have some shapes, 3D shapes given, and on the right side you can see that there are some 2D shapes given. Okay, now for this for you explaining the software, let me turn off my video. I think that would be better for you to understand the software. Yeah, now let me come back to over here. So yeah, now you can see there are these three-dimensional shapes, and here are these two-dimensional shapes. So you can design this antenna using these three layers. Okay, I hope you remember that picture in the mind, the three-layer structure. I will start with the middle layer, that is the substrate. Now the substrate is a three-dimensional structure. So here you have these three coordinates: x coordinate, y coordinate, and the z coordinate. Okay, so this is a 3D. So that means you can design a 3D structure just as if you were designing it in a real life scenario. So take the draw box option over here. Draw box, it will enable you to design a three-dimensional rectangle. Okay, so it's a cuboid. You can draw a cuboid basically. Place it over at the origin, the center. And one more thing I have to tell you, that along the x-axis is the length of the antenna. Okay, and along the y-axis is the width. Keep that in mind. X-axis means the length, y-axis means the width. So and z-axis of course is the height. Now where I have taken this cursor at the center, I will give it one click. I will extend that. Now no need to keep in mind of any accurate measurement. You can do it random. Later on you can change the measurements. I will show you how. Then give it one click. Here you can see a small arrow is showing upwards. Just move the cursor and here you can see a 3D shape is coming up. Then just give it one click. So yeah, see, here we have drawn a three-dimensional rectangular box that is the substrate for this antenna. Okay, now when you have designed this box, you can see that it has come over here as the name box 1, and on top of it you can see it is vacuum. So whenever you design some 3D structure, the software by default gives it a material that is vacuum, empty space. Okay, we are going to change this. First and foremost, name the box and give it the name substrate. Okay, you can also change the color of the box. Let's say I'm giving it this color. Okay, these are optionals. You can do it whatever you like. Yeah, so I've given the name substrate. Now I'm going to change the material of this substrate. So what material am I going to take? I'm going to take the material that was given in this problem. That is the material that will have the reality constant 2.2, because that is the reality constant with which we have calculated the length and width of the patch. So it's 2.2. So let me come back to the software. So we are going to choose a material that has a reality constant 2.2. How are we going to change the material? Just right click on it, go to assign material. Here you will see a list of materials. For simplicity, I will give you the name of the material that will have the relative permittivity 2.2. Over here, see, it is 2.2. I can see Rogers RT Duroid 5880. This material has this 2.2 reality constant. So I've selected it, and now I will click on OK. Now our substrate is ready. Only one thing remains, the dimensions. So for that, go to create box. Just Below the substrate, you can click on the plus and go to create box. Then on the left hand side, you will have a dialog box popping up, where you can see first position. So we have drawn, or we have designed, I should not use the word drawn, we have designed this substrate at the center. So therefore the position is 0 comma 0 comma 0, x comma y comma z is 0 comma 0 comma 0. Now the x size and the y size and the z size, this is what we're going to change. Now what was the length of the substrate that we have calculated? I think we have calculated it to be 50, right? Let's go back to the PDF once more. See, 6h plus L, length of the patch was 40. So 6 into h, 18 plus 40 is 58. We can take it roughly to be 60 millimeters. So coming back to the software, so our length of the substrate would be 60 millimeters. I've typed 60, and let's see what happens when I hit enter. See, you can see the length has changed. Now the y size. Y size means the width of the substrate. Here we have to give the value 70 millimeters. That is what we have calculated. And again, I've pressed enter. Now the z. Z means the height of the substrate. This is 3 millimeters. Again, I will give it enter. Now see, we have given all the correct measurements, but you cannot see the substrate. It is not in your view, right? So for that, you can zoom in and zoom out easily, like just to like you zoom out or zoom in a picture. You can do the same over here, but I will give you a shortcut. Here you can see this option, fit all the contents in the view. Once you click it, see, you can now clearly see the substrate. Okay, you can also zoom in a little bit, zoom out a little bit. So yeah, it is according to your view. You can adjust it, no worries. So we have designed the substrate. Okay, next, the next layer that we are going to design is the ground. So for the ground, I'm going to take a very thin sheet of metal. It's a metallic plate. It won't be, so since it's a very thin sheet of metal, instead of a 3D structure, I can take a 2D shape. Because it's so thin, I am just neglecting its thinness. So I'm neglecting its height. So I'm taking a shape 2D. Let's say I'm taking a rectangle. Now this ground, it is supposed to be just underneath the substrate. Okay, now for that we can do it manually. So just for that, we don't need to give it any dimensions on this left hand side window. We can do it manually, or you can do it if something mistakes happen, you can correct them easily in the dialog box. If you can go to create box, then you can change the dimensions. But let me show you how to do it manually. So place the cursor once again in the center, give it a click, and then extend it. Now keep sure that when you are extending this thing, it always goes to the bottom of the substrate. See over here, I can see that it's at the bottom, right? Now I will give it one click. You can see that this purple color has been given. That means the shape has been drawn or designed. Now see, once I give it a click on the outside, you can no more see that 2D design, right? Why? Because it has gone underneath. So how are we going to say it? Wait a bit. Let's name it first. So here you can see that rectangle 1, the name is given rectangle 1. So you can change it to ground. You can change it to ground. Okay, and then you can give it a color. You can give it yellow if you like, or any color if you like. They give it okay. Now I don't need to change the dimension of this ground, because if I go to create rectangle, see, the x and the length and width are exactly matched as that of the substrate, because we have done it correctly manually. Now we are going to look into that, where is this ground placed, right? So for that, here is an option called rotate around model center. If you click on this option, then you can rotate it. You can rotate the design. It means just as if you are holding this design in your hand, as if. Okay, so when I have rotated it, you can see that this yellow design has been seen over here. Okay, so that means that we have designed the ground successfully. So the 3 layers of the antenna, we have designed 2 layers successfully, the substrate and the ground. Let's go into the 3rd layer. So for that, I'm going to use the top view of the antenna. So I'm going to click on the Z axis. It's a shortcut that I have learned when I was learning it from scratch. So if you double click on the Z coordinate, it will show you the top view of the antenna. So I'm going to design the patch. Now the patch is also a metallic structure like the ground, a thin metallic structure that's going to radiate. Okay. So for that, for the patch also, I'm going to take this draw rectangle. That means a 2D shape, not a 3D one. Now I'm just doing it manually, randomly. I will make the adjustments later on. So I'm going to give it a click. So it's a random shape that I have taken. I'm going to give a click once again. Now I have made one mistake. Okay, so see, this mistake happens when you are doing it manually. You may see that what mistake has been happened. Nothing has happened. We have drawn this rectangle successfully, right? No, wait. If I click on the outside, you will see this shape will vanish. Let's see. Yeah. So it's not magic, guys. What has happened is that this shape has gone by default to the ground of the antenna. Let me show you. If I rotate it, see, you can see that this shape has been, it's in the ground of the antenna. So how are we going to fix it? Let me show you the top view of the antenna once again. Now it has come the name as rectangle 1. First change the names, always change the names, because later on you may get confused about which one is the ground, which one is the patch. So give it the name patch, and I'm also giving it a color. I'm going to keep the color same as the ground because they are actually they generally are of the actually of the same metal. Let's say the ground is copper, so the patch also will be copper, generally in the case, but it also varies. Okay, now I'm going to click on OK. Now I'm going to go to create rectangle to change the dimensions. So let me start with the length and width. Okay, so what have we seen? The length and width. The width is 50 millimeters and the length is 40 millimeters. So let's do it quickly. So the width, length means x-axis, so it's 40 millimeters. I've given enter, and the width is 50 millimeters. Again, I've given enter, but still we are not able to see the patch, right? Why? Look at the position. The position is, and the in the last number, you can see it's 0. So the last digit is actually of the z coordinate. It means it shows the movement in the z axis, right? So it is in the 0 means it is in the ground plane. So if I give it, if I'm going to make it come top of the substrate, I'm going to give it a number that is equal to the height of the substrate. Understand it carefully. This patch which has gone underneath the substrate due to manually doing it manually because of the manual work, if we are going to lift it to the substrate, we are going to give it the height of the substrate. That is how it is going to move up, right? So the height of the substrate is 3 millimeters. If I give the value 3 instead of 0, and now if when I will hit enter, you will see the shape on top of the substrate. Let's see. Yeah, you can see this shape on top of the substrate now, but this is not how the patch should be placed. The patch, according to theory, should be placed to the center of the antenna. Let me place it to the center. Okay, so I'm going to go to create rectangle, and I'm going to change the positions. So I want this patch to go a little bit towards to opposite to the y direction. The y direction is pointing this side. I want it to go opposite to the y direction, so I can reduce the value. Let's see if I give it 12. So see it has moved opposite to the y, right? So it will work according to your way, guys, how you want it. Let me give it 10. Okay, so it has moved further, but you may wonder that how am I deciding that it is in the center or not? Am I just by looking at it, are we going to decide it? No. For that, just click here, just deselect the rotate option and click on the patch. Click on the patch and look at the squares on the left and right side of it. On the left side, you can see these two squares over here, two cells. On the right side also you can see these two cells. That means that the patch is at the center, at least along the y-axis. Now I have to keep it at the center along the x-axis. Okay, so for that I need to change the value in the x1. So 15. Now I want the patch to move a little bit up. Up means opposite to the x direction. So I can give it the value again 12. Let's move up. I want it to be more upwards, so I can give it 10. Yeah. So now if I click on this patch, count the cells. Now don't count the cells on the left and right side, because now you are checking it on the x direction. So count it up and down. So in the top side you can see 2 cells, on the down you can see 2 cells, right? So now the patch has been designed successfully. Okay. Now, one more thing remains, that is that you are going to supply a current to this patch, right? Because otherwise, without any power source, the patch won't be radiating. So you are going to make an arrangement for the current or the power to flow into the patch. So for that, we are going to have another design, and we are going to call it feed. So here, take the 2D shape rectangle, click it over here, and make sure that you are just going to the edge of the substrate, not beyond it, and then give it a click. See, here we have designed a small rectangle that we are going to name it feed, but once again we have done it manually, so it has gone underneath the substrate. First things first, name it feed. Feeding means to some, feeding some food to someone, right? So here feed means providing power to the patch. So it's the path where through which the current can flow to the patch. Okay, so I have given it the name feed. Now I'm going to go to create rectangle under feed, and I'm going to change this to 3 millimeters, the height of the substrate, same as what you have done with the patch. Now I'm going to click, and now I have clicked enter. So see, the feed has come up the patch, but I don't think it's at the center. No, I want it a little more to the y direction. So I will change 30. I will change it to 32. Let's see. Now if I click it, count the cells. Yeah. So I think it's almost at the center of the antenna, the patch. So now we have designed the feed as well. Now, this feed that we have designed, there's a way to insert that feed into the patch. This will improve your design in many factors, keeping in mind of the efficiency, loss. In such factors, if you want to improve the design, you're going to insert the feed to the patch. So for that, just click on the patch. Now whenever selecting two items at once, what you do in general in a computer, you press the control option and then click on the other item, right? Over here, do the same thing, press the control option in your keyboard and then click to feed. So the two designs have been selected simultaneously, the patch and the feed. Now after doing that, go to this option, unite. So then click on the click outside. Now we have designed this microstrip, a basic design of this microstrip patch antenna, where it has this ground plane, the middle portion, the substrate, and the patch over here. Okay. Now we had not done yet. There is much things to do right now. Okay. First of all, one thing is left, that this patch on the ground, we are going to give it a metallic characteristics, means we are going to make it a conductor. Second, we are going to give it a power supply to the antenna. The current will flow through this feed. The current will flow through this feed, but the current to flow, there must be a power supply, right? Now in the software, how are we going to give such a power supply, right? So we are going to give it a power supply. First is what we are going to make the patch and the ground electric conductor, a metal. Second, we are going to give a power supply to this design, and third, we are going to simulate the design. So these three things are left for now, but I think you have seen an overview of how to design a microstrip patch antenna using this HFSS software. In the next part of the video, I'm going to discuss, and I'm going to move ahead with these three pending tasks. Okay, so that's it for today, guys. I hope that you have enjoyed this video. Practice this designing at your homes using this software. It's a very easy software. You can install it easily. You just need to know a few basic steps. Later on, I can also come up with a video about how to install and run this software in your desktops or laptops or computers. So yeah, practice this, and in the next video I'm going to come and I'm going to continue and I'm going to finish up this work that I have started today. So Good day to all of you. Happy learning.